Hi students, this is AJ sir. Let's study 10th standard ICSE math, exercise 5E and F, quadratic equations, miscellaneous. Exercise 5E, quadratic equations, miscellaneous sums. First sum. Here we notice that the denominators are different, but if you take the LCM, it will match this denominator. So that's what we'll do. We'll take the LCM so that we have a common denominator and bring all the numerators together. Open the brackets. Here the denominators can be shifted to the RHS. That becomes 0 as usual. And after opening the brackets, we get a quadratic equation divided by 2 and simplify it. Here we can split the middle term. After that we get 2 roots of x. So x is equal to -1 or -3/2. But in the question, they had mentioned that x is not equal to -3/2. So the final answer has to be mentioned as -1. Don't forget to do that. The reason why they mentioned that x is not equal to -3/2 is because if this were possible, that would have resulted in a contradiction. You see, if I just substitute this value in place of x out here, then this denominator becomes 0. And how is that possible? Nothing can ever be divided by 0. Now the third sum. This looks like a formula a squared minus b squared. So when we open the brackets, we get a plus b. A minus b is equal to 0 using the formula. So either this is equal to 0 or this equal to 0. Shift all the terms to the RHS. I want x alone. So we get two values of x, minus b upon a or b upon a. Next, cancel sum number 5, 6 and 7. Let's do the ninth sum, which is IMP. Notice that these two brackets are quite similar, but not exactly the same. Obviously we will replace them with y, but how? We can assume x plus 1 upon x as y, but then what about this bracket? Well, after assuming this to be y, let's square both the sides. So this becomes a squared plus b squared plus 2ab. By the way, 2 into x into 1 upon x will be just 2 because x and 1 upon x are reciprocal. So when you multiply them, they disappear. And if you shift the 2 on the RHS, we finally get the value of x square plus 1 upon x square in terms of y, because it has now become y square minus 2. So now we can substitute these values of y and y square minus 2. So it becomes a quadratic equation in terms of y, which can be solved further by factorization method. Split the middle term. You see 2 into 15 is 30. So I need two numbers such that their product is -30, but their addition is -1. So that's -6 and 5. That's a perfect combination. You need to work it out in the rough work. And finally we get 2 roots of y, that is 3 or -5/2. But the sum is not over yet. Don't forget to resubstitute the value of y, which is x plus 1 upon x. So you notice that after resubstituting and removing LCM, again you get two quadratic equations. So solve one at a time. You can do it one below the other as well. If you look at this, there is no way we can split the middle term. So we have no choice but to use the formula method for this sum. Comparing, we get a, b and c values. Find the value of b square minus 4ac first always, because if this is a negative answer, then this part stops right here, because then the roots will be imaginary, not real. But here the roots will be real. In fact, they will also be unique. Two different answers will come. So these are the two answers we're getting: 3 plus root 5/2 and 3 minus root 5/2. Now let's solve the other quadratic equation. Here also you may use the formula method if you want to, but I prefer the splitting the middle term if it's possible. So 2 into 2 was 4. So 4 and 1 are the combination, and I got two answers, -2 and -1/2. So finally we got 4 roots of x, which makes sense because the original quadratic equation, if we would have removed the LCM, it would have been with the power of 4. Highest power is 4, then the number of roots will be 4. Next, the 11th sum is also IMP. Here they've given a hint, but in the exams no hint will be given. If you want some hints to be included in the question paper, then you'll have to transfer some of your bitcoins. So here we're going to take x squared plus 5x as y. So it will become y plus 4 and y plus 6. Another way would be to consider x squared plus 5x plus 4 as y. So that this would become y plus 2 because 6 is 2 more than 4. Anyway, we'll go with the first method only. So after substituting it as y, we get a quadratic equation in terms of y. Here we can split the middle term. So that's what we'll do. And we get 2 roots of y. Don't forget, resubstitution. So we get 2 more quadratic equations. The first quadratic equation, it's not real. So no roots here. But here splitting the middle term is possible and we get 2 values of x. That's the final answer, minus 6 and 1. Next sum, 12.2. We have to solve it up to 2 decimal places. We've done such sums before, nothing new here. First we find the value of b square minus 4ac. Root 85 we find out using the logbook table. The square roots are given. Calculations are a headache, but you need practice. So don't just copy these answers. Actually solve it and check if you are getting the answers. That will boost your confidence. And they said up to 2 decimal places. So let's put a line out here. We can ignore the 3, no worries. But here, if I ignore 9, I'll have to increase the previous digit by 1. So it will become 1.37, accurate up to 2 decimal places. Now, the 13th sum. So it's pretty obvious that x upon x plus 2 will have to be assumed as y. So that's what we'll do. We'll get a quadratic equation in terms of y. Make sure you mention the assumptions. Split the middle term, get 2 values of y, resubstitute, cross multiply. Fortunately, we don't get 2 new quadratic equations. In fact, we get linear equations, which is pretty easy to solve. And we get 2 answers of x, minus 8 upon 3 and minus 3. You may choose to change it into a mixed fraction. 13th sum is done. 14.1 can be cancelled because it's easy enough, the same type. 14.2, solve. Note here, x should belong to integers, so keep that in mind. So after splitting the middle term, we get 2 values of x. Integers include negative numbers as well, so we will have 2 answers, 6 and minus 2. We won't reject either of them. If there was some decimal answer or a root answer, then that would have been rejected because x is given as belonging to integers. Now the 16th sum, it's an IMP sum. So when we look at this, the first thing that should come to our mind is let's bring all the x's together. I mean the x variable together. So we will shift this on the RHS. It becomes minus 1 upon x. And here LCM into Q into Q into P into P. So we have a common denominator on the LHS and the numerators can be brought together. Similarly, even here into x and into x plus p plus q into x plus p plus q. So again the denominators are same, bring the numerators together. There's a minus sign out here, so when you open the brackets everything becomes negative, minus x minus p minus q. Don't forget to do that. So x and minus x get cancelled. And this minus sign can be removed common, so we'll get p plus q. And p plus q is same as the p plus q here, by the way. So we reach this step and then cancel p plus q and p plus q. So what is left is 1 upon pq is equal to minus 1 upon x into x plus p plus q. Cross multiply them. This goes up here, this goes up here, and we get this. Open the brackets. Shift this minus pq to the LHS. So finally we get 4 terms. Do the pairing, first two and the last two. Here take x out common and here take q out common. Brackets are same, so that will be taken common and the remaining terms in another brackets. So either this is 0 or this is 0. That means x is either minus p or it is minus q. Next 17.2. So here we'll have to take LCM. Otherwise it's a very straightforward sum. Take the LCM of the LHS. Be careful with the sign out here. There's a minus sign here, right? And similarly take LCM of the RHS. Again, when you open this bracket, minus into plus will become minus. Sign errors are the number one common silly mistakes made by students. So be careful here. So finally we reach this. We have opened all the brackets now. So let's cross multiply. But before that, minus x and minus x gets cancelled. That's good. So this goes up here, this goes up here. When you're transposing like this, signs don't change. Now rearrange all the terms. X square cancelled. That's nice. Now we don't get a quadratic equation. Instead, we get a linear equation and we get the value of x as minus 5 upon 2. However, there is one big assumption we have made. When we cut x and x, we have assumed that x is not equal to 0. Remember, in many sums, in the question itself they mentioned that such that x is not equal to 0 or x is not equal to 3. So we have to keep this thing in mind that x could have been 0, so that is also a part of the solution. If you can't remember this, then rather solve like this. So again, you get this equation after cross multiplying. Don't cut x and x. Shift this out here, shift this out here. Just cut the minus and minus signs. Keep the x. Then you open the brackets. You get x cube and x cube. X cube can be cut. That's fine. So finally you get this. 2x is common. And this means either 2x is equal to 0 or the brackets is equal to 0. That means either x is equal to 0 or x is equal to minus 5 upon 2. So don't forget to mention that x can be equal to 0 also in this sum. So mark this sum as IMP. Now 18.1 cancelled. Now 18.2. We have to solve this and get the value of m such that the roots are equal. If the roots are equal, that means b square minus 4ac will be equal to 0. That is, the discriminant will be equal to 0. So first of all, compare and get the values of a, b, c. b square minus 4ac is 0. Solve this and get the value of m. Then when you substitute this value of m in the real original equation, you get this quadratic equation, and then you can simplify it, dividing by 3. Splitting the middle term and get the two roots of x, and of course you'll get both the roots as minus 2 because they had mentioned the roots are equal. Next we can cancel the 19th and the 20th sum. Let's go ahead with the F exercise now. Cancel 1.1, 1.2. Let's do 1.4. You can see that the first thing we'll have to do is get rid of that umbrella, that root sign, by squaring both the sides. So the square root goes away on the RHS, but now on the LHS we have whole square. So we'll have to use the formula a squared plus b squared minus 2ab. On solving further and get the like terms together, we actually get a quadratic equation. Dividing by 2 is possible, so let's do that. And now solve it further normally, splitting the middle term and get two values of x, which is 6 and minus 1. Next, question number 3. Show that one of the roots of the quadratic equation is minus 3. How can we prove that minus 3 is a root of this equation? If you remember, we will substitute the value of x as minus 3. And then if the LHS matches the RHS, that means it satisfies the equation, which means indeed it is a root. And then we'll find the other root as well. So first things first, start with the LHS, substitute the value of x as minus 3. Yes, A is unknown, that's okay. Ultimately, the answer will be 0. So, x is equal to minus 3 satisfies the equation, so it is a root. Now, to find the other root, we will solve it. Now, don't substitute the value of x again. No, just open the brackets, take two terms at a time, remove common, x plus 3 is a common brackets for both. And finally, we have two values of x. Minus 3, obviously, we knew this. But the new answer, x is equal to 2a, is the other root, so highlight that. The next sum will be the 7th sum. Cancel question number 4 and 5. Solve using formula, they mentioned. So we'll have to compare it and get the value of a, b and c. Note that c is actually minus a plus 2, a plus 1. Now b square minus 4ac, substitute the values. Use brackets, they are for free. Here minus into minus becomes plus. Now opening the brackets will be a little tricky. Multiply with 4 later. First let's multiply these two brackets here. And then open the brackets so that we can do distributive multiplication with 4. And finally we get this. Notice that this is actually a perfect square formula. It is a square plus b square plus 2ab. That's 2 into 2a into 3. That's 12a. So this is a perfect square, a square plus b square plus 2ab, and the formula is a plus b the whole squared. So we have condensed it into this form, which will be useful because when we start using the formula, then the square sign and the root sign will cancel each other and we'll get something simpler. We will separate them so that we can add and subtract accordingly. Here, if you remove 2 common, then that can be cut with the denominator. Same thing here, can be cut with the denominator, and the final answers we get are a plus 1 minus a minus 2. So a very unique sum, this one. Next, we can cancel questions 9, 10, 11, 12 and even 13.2, and let's solve question number 13.1. So nothing unusual about this sum except for the fact that while taking the LCM, so into 18 plus x into 18 plus x and here into 18 minus x into 18 minus x, we have to be careful about the sign. When this brackets open, it becomes minus 18 and minus into minus plus x. So don't forget that this sign changes. The denominators are now together, but this is of the format a minus b, a plus b. So that is a formula, a square minus b square. So we can now cross multiply them to get a quadratic equation. Splitting the middle term, well, 324. You should find all the factors of 324 and check all the combinations which work, which when added or subtracted give you exactly 48. And the combination I got after a lot of efforts was 54 and minus 6. So you too try it out, put in some efforts. And finally we get two values of x, minus 54 and 6. However, in the question they had mentioned that x is greater than 0. Don't ignore such information. So x cannot be a negative number or even 0. X is a positive number. So the final answer has to be mentioned as x is equal to 6, failing which you will lose marks. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.